So we have the handoff. So this one just remind you of a handoff. And with the handoff later, in fact, we want to have the consideration of handoff. And even we want to have the modeling. So we need to have the preparation of modeling to cover possible resources if we consider handoff codes. So here, same, we just want to let you know, oh, okay, we have a handoff. So this one actually, we ever use the slides in chapter 1. So here, as I don't know, later we want to have the modeling. Maybe for you, you think it's the advanced modeling. Why we want to have modeling? Actually, we still care about resource allocation. Well, resource allocation can be modeled. Yeah, sure, we can have a model. So later, maybe we don't have the details about system modeling. And the details of system modeling to have the schedule model for resource allocation. And also, we consider handoff for sure. So that says, first of all, we have the following assumption. And this one, first one, all mobile stations are assumed to be uniformly distributed through the cell. So someone like, oh, okay, we have the random position for the mobile station. Even we have this one, but this one is just assumption, so we don't use it directly. We mention, okay, random position for the mobile station. And the random position, then we have the random speed and the random direction pathway. So someone like we try to have the initial position and the initial speed to move. Even initial speed to move, we may alter the speed later. Normally, we should have something like that. For example, someone like when you ride a bike, so do you have the constant speed? Normally, no. So someone like that, oh, okay, this time I have the direction. For you, maybe you want to ride a bike towards a specific, maybe destination. So you will have the different direction, but finally, you may reach some destination. And currently, we don't care about the destination, so that's why we don't have the assumption, oh, okay, random speed and random direction. Of course, we have the random position. So up to now, two assumptions to cover the two ideas. And actually, think about this, if we have an area here, how to determine the handoff rate, handoff code rate. In fact, if I move to the other cell, something like I open the door and then leave. And then this is the handoff rate. Normally, we should follow, okay, some mobile station with some specific direction. And so they move towards that direction. So we will have the handoff rate. But currently, we don't follow their idea to have the exact modeling. So we have the simple assumption. Okay, so arrival rate, originating code. Sure, we can follow the current rate. However, how about the handoff rate? Okay, someone will find the rate for me. So I just try to have the given handoff rate. Actually, the given handoff rate will follow the assumption originating code rate and the assumption about this. And so that handoff rate can be related to the originating code rate. However, right now, we think, okay, someone will derive it, so we think we can decouple the current rate. And so that it seems to be, we have the individual rate, one originating code and one handoff code. And we can treat, oh, they are irrelevant. In fact, no, they are relevant. All right, they are relevant. But how to relate handoff rate to originating code rate? We may have the detailed model so that we can find indeed the relationship between originating code rate and handoff rate. Well, so Right now, we keep it simple. So, okay, something like given, at least someone can find it. Even someone cannot find it from the viewpoint of performance investigation. So we can think, okay, the current one, for example, given value 1, value 2, value 4, value 5. So we can have the different values given. And so that we can have the corresponding performance shown by different handle rate. And so that we know, okay, how about given value 1, 2, 3. So if we have the different value, then we will reach the different performance. So we can use that way. So right now, we just follow this way, and we think, okay, we can have the given rate, handle rate here. And of course, for the code, someone like, oh, okay, we are homogeneous. Homogeneous means we can have the common requirement by the mobile station. By the mobile station, so that says we can have the same service requirement. So that we assume the code rate followed by the same rate. It's mu. All right, so that says, oh, okay, if we want to measure the code duration, we can have the common mean. Common mean, then we can have the common rate. All right, so mean and rate. Mean duration and the rate, actually, they have the relationship. Mean service time actually is the reciprocal of the mean rate. And so we have the fixed relationship. So that's why I code we have the common mean service time. Because of a common mean service time, so we have the common code service rate here given by mu. Why we want to have all the notation? Because we want to have the current channel allocation modeling. And this modeling actually forms the system we want. So what kind of system? Here we have channel 1, channel 2 to channel S. Well, something like here we have a cell. Within the cell has been allocated, the cell has been allocated S channels. With the S channel, then we want to consider, oh, okay, we want to have the performance for originating codes and the handle code, put them together. So we want to measure the corresponding performance. So this is the simple one. Even for originating and handle, we have the common service rate. With the common service rate, later, sure, you may have the given problem. Oh, okay, handle rate and originating code. So how to have the proper channel allocation? So if we have a highest priority for handle, so how to do? So some idea like this, so we can have the different system model, but at least we have the simple one. Oh, okay, originating code and the handle code, both of them should compete the resources without any special treatment. So this is the first one. If without any special treatment, then how about the performance? Performance perceived by originating code and handle code, they are the same. Well, so this is the first one. No difference for handle codes and originating codes. So that this is a generic system model. We start from this generic system model. Well, for that system model, in fact, we want to know the performance. What kind of performance we can have? Right now, here we have probability of I channels to be busy. Later we can show the diagram. And currently we have rate. But this one, the first one, we have a blocking probability. So currently the measure should be blocking probability. All right. So what is blocking probability? blocking probability says if I request service, however, no channel to be allocated to the mobile station, then that mobile station will be blocked. For example, we can ask station 1, try. Station 2, you can try station 3 and 4, and for example, to station 10. After trying, then 3 mobile stations got blocked. Then the blocking probability should be 3/10. So this is a blocking probability. And right now we care about originating code. So of course, we just care about originating code. For example, using the similar way, originating code 1, 2, 3 to 10. Each try to check the resources. Will the code be blocked? If yes, then we have a mark. And maybe 3 codes blocked, then 3/10, then we can have the blocking probability. So currently, we care about this blocking probability of originating code. Is it possible to have the similar blocking probability, but we care about handoff code? The answer is yes. So we can have a blocking probability corresponding to the handoff code. For handoff code, then we have the specific name we call false termination probability for the handoff code. So handoff code, actually we can have a different name, and this name can let you feel, okay, yes, we have the ongoing code, but the code is false to be terminated. So we have a new name, false termination probability for the handoff code or associated with the handoff code. But right now we don't mention that one. Still, we will care about that kind of probability, but that kind of probability, you still can call its blocking probability of the handoff code. Or maybe you can call its false termination probability because it's an ongoing code and the ongoing code is false to be terminated. So we have the false termination probability and the others. And here we have the different notation. We have this code duration. All right, code duration. So this way, here we have a maybe at least we have the different one. Code duration. Code duration and the current cell provide you the service rate. That says, okay, within the cell, the duration governed by this. But for the code, actually, we may initiate the code from cell 1, but end at cell 10. So code duration actually is the whole duration. But the service rate, if we focus on that cell, so we may have cell duration within cell 1, cell 2, cell 3, and the other. So in fact, they are not the same, but we have the code duration for you. And actually, we can have outgoing rate leaving the cell. Even we mentioned this, but we can pass our model, but we mentioned some of these for you for the preparation.